very, very key basic issues. So we had to look into how do you jump from the scale of 1 to, say, 10,000 of making sure that there is a regeneration program going on that makes sure that the members of the village don't leave the village, but also go inside and try to maintain the historic center, but that also are able to address agriculture, water, electricity, and so on. So the first thing was, let's see what are the practices. So we started to map and try to identify potentials that exist already. Simple, basic techniques. We thought this is important. If they can do that, that means they know they need shading. If they can provide shading, they need less energy to produce cooling inside the building, etc., etc. These are very simple things. Nobody can destroy it. They can't control this, outside powers, but we can, from inside, from underneath. And these are the things which we identified, so we thought the first thing to do is to make sure these little potentials are connected to each other. People have already very interesting habits of taking the shoes off, which is very important. One of the things that we're doing also researching on how some very basic habits like taking your shoes off, hanging or washing, and having it after sleep, how does that reduce the use of energy? We can talk about that another time. Courtyards, use of courtyards and hanging or washing was another thing. So we thought we'll do that. And also we noticed that quite a lot of the houses already use these simple ventilation techniques. So they know there's a local awareness, there's a basic awareness. So we can build on that. And of course agriculture and rules of recycling some of the materials in order to maintain their agriculture. Of course in Hajj, like many other villages, historic centers in Palestine, agriculture is dying, as you know, and I don't need to tell you why. So what we did, we sort of used one building in the historic center, stone building. We started to measure it with temperature measurement of how the building actually practices, how does it breathe and how does it live. And we made a model. We're working with Arab engineers in London on this project, also with a couple of professors at the University of Westminster, on making sure that, first of all, some of our studies stands up to some of the tough demands. One of the things that we did, we set up a thermal comfort temperature, because that's an important issue. How do you make sure that the building that you're designing, all the kind of services that we're going to be designing for, it works under a thermally comfortable stage. And we realized that these stone buildings, which are quite massive, they've got quite massive thickness, they actually do quite well in the different temperatures. They stand up, but then it's good for cooling, but actually not very good for heating in terms of temperature. So how do we deal with that? So we started to look into introducing very small techniques in order to control, one, ventilation, which means that if the building is ventilated well, I'm sure you'll know it, then you don't need to produce a lot of air conditioning or heating or cooling, and you get clean air. So secondly, the important thing for us was to make sure that the heating is produced with minimum energy. Massive amount of sunlight we have in Palestine. It's one of your assets. So we realized that with a very simple thermal panel, we calculated it through the heat loss and heat gain and how much we can, with very simple thermal panels, have underflow heating that will keep the place, the historic buildings warm. We introduced very simple cuts into the parts of the building in order to make sure some sufficient light comes in so these historic buildings can actually work on the daylight, which is one of the key things again. If, as we know, if a building at daytime you have to turn the lights on, there's something wrong. Yeah. So this is something that, and we also started to make sure that some of the experiences that we learned from our project in Iran with the prototype, the panels can work. So we are thinking about introducing certain kind of cooling panel system inside the walls, and always trying to introduce another thing. One of the things that we want each time that we do a project, which we do it scientifically, we're trying to make sure that in terms of the use of electricity, it reduces the bill in terms of air conditioning and so on, but also we introduce trying to bring back little practices, like just a simple act of washing your face before you go in. It drops the temperature of your body by 30%. Now that already means the amount of air conditioning you want to use, if you have to use it, will be reduced. You take your shoes off, that would be another reduction in the requirement for that, etc., etc. And so this kind of more unscientific, if you like, but culturally embedded in our everyday practices, plus the scientific, is something that we are looking at, and we think this is what is needed, not only in the Middle East, but in Europe now. We're doing a project in a knowledge partnership practice with another European organization that we're trying to introduce that also in England. So it's not just here in the Middle East. This is the green wall which we introduced into one of the historic centers, which is also cooling. It's not just green wall. Also, we work with Arab engineers. I don't know where this is at. So this is the project we're working on right now in Hajjah. There are 5 buildings or 5 rooms basically. So we're introducing certain kind of 2 courtyards. We actually introduced a very new idea that we have 2 entrances to the building. At summertime, we come through the north, which is very cold, protected. At winter time, we come from the south, which you capture the sun. And just this issue of introducing different practices in summer and winter is just an awareness in itself. It just reminds us that, hey, we can come in from a different. That means you come in on this south sun in the winter. You come in at the cool place. And also what we did, which I'm going to go very fast at that. So this is our strategy for the village to reduce the use of energy and living and working places. So we started with that model already, and I think the contractors are clearing at the site. So in fact, tomorrow afternoon we're going to, Saturday we're going to look at the site and start to address some of these. Reduce the use of energy by improving the building fabric, introducing thermal mass. Some of the areas of these stone buildings are not as good as some other parts of it, so we wanted to reintroduce some kind of insulation, again calculated very well. And the issue of reducing the sand filter and recycling the water. Now this is very important because water has massive shortage in most historic centers, most places, not only in Palestine, everywhere. So what we're looking at is 2 things. How do you stop the waste of water? So we're introducing recycling, grey water use of water from sink to the WC for flushing the toilet, but also sand filtering water wells, because in Hajjah there are water wells, so we want to introducing sand filters. Again, we're working with engineers. Our engineers in the team are introducing 2 types of filtration. One which would allow the water to be used for drinking, another one to be used for agriculture. And then the use of existing networks, important at the same time that we're doing that, we're trying to make sure that the community as a whole and the municipality can also address the issue of agriculture. So we have to help them to make sure that they can sell their product, to compete with the Israeli market, and also to make sure that the agriculture doesn't disappear. And there are other bits and pieces like provision for street lighting, furniture, etc., because these are also very important part of things. Because if we make the streets livable, shadeable, then again there is that weight from the areas of the building which you can protect it in terms of shading, then you can reduce the amount of heat that penetrates into the building. It's all part and parcel of the same kind of idea, same protection. So here it is. These were the kind of measures, summer and winter entrances, which I talked about, water wells, the washing of the face as you enter. We placed it on one of the water wells as you came in. You would address that. Then introduction of openings into the walls and roofs, because almost every room, 1 minute, yes, one more slide. So, almost every room that we measured failed in terms of daylight. So even though there are places, there's times when you go to a building, you go to a room, you think it's okay, but actually it's not when you measure it, when you do testing and do the calculations. So we introduced certain openings, solar chimneys, which were very important to pick up some heating, thermal mass introduction, and air tightness at the bottom is very critical, very important, and water wells, which I've spoken about. Finally, this project we actually did in Feasibility. We also started working with it, which is ongoing. But finally, last project, we went to Gaza last October, after a long time working with UNDP and UN Habitat, a number of other, the Islamic Relief and the other organizations inside. And that's actually one of our big things now. We're trying to address the issues, because as you all know, Gaza is very close. It's not far away. It's very close to us here. And it's very close to our heart, of course. And Gaza is in need, and now this is what we're concentrating on. And we're trying to make sure we work with very skilled workers in Gaza and with very difficult conditions. But the potentials are there, And only last week, when I was in Jerusalem, I had a meeting with UN again. So we hope to go back. We're having another meeting next week. But again, the issue of energy, reduction of energy, recycling of materials, and building back better is the key thing. Thank you.
Thank you, Mr. Golzari. طبعا بعد نهاية البرزنتيشنز للأربع متحدثين نفتح المجال للأسئلة لمدة 20 دقيقة. برجو من الطارح السؤال انه بالبداية يعرف عن نفسه ويطرح سؤال واحد فقط، وقدر الإمكان يكون طرح هذا السؤال مختصر ويحدد بالضبط مين السؤال. شكرا.
يعطيكم العافية مهندس رامي. سؤالي, my question for Dr. Bruno, what is constraints or conflicts that face the use of CPS technology? What is the constraints or conflicts that face the use of CSP technology more than solar radiation, other things in technology, not in solar radiation?
Really, I didn't catch the question. I catch the words, but I didn't catch the point that you want to make. You mean that there are some constraints that there are, so in a certain way, not allowing a full deployment of the technology?
Yeah.
Oh, I don't see this, because I was showing that the technology, the applications are really growing in a very fast way. So then I don't see that there are still some barriers that are very, very huge. Now it's simply that we have to be convinced more, but the technology is already at the point that I was showing that is reaching the parity with the very measured technologies. So then we are at the point that really we can deploy this, but this doesn't mean that we have to stop research in this, because research is still important, and the key point of this is the fact that still the storage of energy is really the most important problem connected with all renewable energy sources. Now it seems that with this technology there are some hope to solve these problems, because now they are developing a lot of materials on which you can store the heat according to the temperature that you need. You can, if you have to store it till, I don't know, around 500 degrees, you can use the so-called molten salts. There are some salts that you use also in agriculture. It's very, very cheap material, that they can stay liquid till this point without decomposing. If you need to store it at a higher temperature, maybe you can store the heat in sand materials, because with the stream of heated gas, you pass there within the stone that they get heated, and then you store energy, and then in the night you can recover energy. But there are complex strategies to really manage then the energy that you get during the day, and you send right away to the turbine. But then you have to say balance. Maybe in this time I will send to the storage. Maybe from the storage I will use it there. But essentially, I don't see that at the moment, because the market is really fast growing, and we stay already at a position that is the industry that is pushing for further research. And this means that we are already bypassing the critical points. Because at the beginning, you know, that all the basic research is made by the public, by academia. But now we are, at this point, we are already invented. So this means that the market is really starting.
سؤال آخر لو سمحت. تفضل هون يا
المهندس إسحاق العامل.
تفضل هون.
المهندس إسحاق العامل لمكتب التضامن الهندسي. يا سيدي، أول قضية بالنسبة للدكتور مروان لما حاول يقارن بين سرعة الرياح ل 5 متر بير سكند و10 متر بير سكند، حكى انه اذا كانت فيها 10 بصير 40، حقيقة بصير 80. خير وسيله حمايه. سؤالي انا للمهندس ناصر والدكتور ناصر. يا سيدي بخصوص المستشفى الاهلي، في مجال تقدر تعطينا رقم قديش كميه الطاقه اللي راح تكون من طاقه الرياح؟ طبعا اللي عرفنا انه 375 كيلو وات بالنسبه للجنريشن او بالنسبه لا يعني للجنريتور بدون حط هيك وضع، بس من ممكن تقدر تعطينا قديش ممكن تعطينا باليوم؟
سؤالك موجه للدكتور عماد قصدك؟
دكتور ايوه دكتور عماد. كم كيلو وات اور ممكن تعطينا في اليوم مثلا على الوضع الموجود؟ لأن أنا أشك في القضيه لما نقول احنا نتناسب مع مكعب سرعه الرياح، نقول انه عندنا سرعه رياح تقريبا 6.5 متر بير سكند، بتحكي عن فروق كبيره جدا، بالاضافه لامور اخرى يعني الحقيقه وقتش الدقه، معناته في دراسه ممكن تعطينا قديش كم كيلو وات اور في اليوم مثلا، او قديش معدل كم كيلو وات في الساعه، يعني كيلو وات اور في الساعه.
يعني تم عمل دراسه بحيث تم تحديد قديش الويند توربين رح يعطينا بالشهر على السرعات اللي تم اخذها على مدار الساعه على مدار الشهر الواحد، وتم عرضها في البرزنتيشن تبعتي. فهي للتوربين 330 كيلو واط تقريبا رح تغطي 20% من استهلاك المستشفى بالكهرباء، وهذا ما يعادل تقريبا 250 ألف كيلو واط اور بالسنه. يعني لم تحسب، ما تقدرش تحكي المعدل في اليوم. اذا بتحكي معدل الويند الافرج ويند سبيد للموقع كان تقريبا 5.6 متر بير سكند، عند 5.6 متر بير سكند تقريبا بيعطينا الويند توربين 330 بتكون تقريبا 170 180 كيلو واط، بالتالي 180 كيلو واط بير اور. هذا الافرج على مدار السنه، ولكن مش راح طبعا مش راح تكون عندي الاوتبوت انرجي في كل يعني المعدل هذا راح تكون كل ساعه من ايام السنه، عشان سرعات الرياح زي ما انت شفنا بتختلف باليوم الواحد وبتختلف من يوم ليوم، بتختلف من شهر لشهر.
شكرا لك. اسمح لي اجاوب بس فقط تعليق بسيط يعني مع زميلي الدكتور عماد اللي تفضلت فيه. اول شيء مثل ما احنا قلنا انه اذا بتتضاعف سرعه الرياح، يعني اذا ما يعني سرعه الرياح تنتقل بتصير من 5 إلى 10 متر، معناها اضربها في 8 بتصير 8 اللي لاحظته انت صحيح. ولكن سؤالك للدكتور عماد، اذا انه احنا عندنا الريت باور للويند توربين اللي بدهم يركبوها اللي هي بحدود 13 متر بير سكند النومينال ووراه في الكيرف، اذا نصها قديش بده يكون بدك تحصل فيها اذا انه عندك يوم 6.5 متر بير سكند مثل ما تفضلت تحصل على 41 كيلو وات بهذا اليوم.
هذا سؤال بعدين وصفتوا انا. هل في هون لو سمحت هون وانت بعديه لو سمحت.
مهندس احمد حداد. السؤال الاول للدكتور عماد البيك بالنسبه لمشروع المستشفى الاهلي. لاحظنا ان سرعه الرياح، معدل سرعه الرياح في الاشهر من تقريبا سبتمبر لديسمبر كانت سرعه عاليه الافرج، بس شفنا انه البرودكشن اوف انرجي كان اقل ما يمكن. هل هو عشان الكت ان ولا الكت اوت سبيد؟ هذا السؤال الاول. السؤال الثاني
سؤال واحد للاسف ما نقدرش نلخص سؤال واحد لو سمحت.
شكرا.
يعني بوث بالفعل عند سرعات رياح عاليه جدا كمان، خصوصا في المنطقه اللي راح يكون فيها موقع التوربين هذا، عند سرعات رياح عاليه جدا فوق ال 25 متر بير سكند واقف التوربين هذا، فالكت اوت سبيد للتوربين كانت 25 متر بير سكند، فبالتالي هي ناتجه من انه كثير من السرعات كانت تحت الكت ان ويند سبيد للتوربين.
في اي زميلنا هون لو سمحت.
Rimaya from Al-Quds University. I wonder if I can ask two questions in one. Okay. Professor Bruno, you showed a slide about concentrating the solar energy. One of them is you are putting, I believe, a Stirling engine in the focus of the solar dish, right? Actually, I followed this subject, and okay, you can concentrate up to 4 kilowatt of sun. However, the Stirling engine efficiency is, you know, about 15%, and you end up with only 0.6 kilowatt. And that's not encouraging really. You know, if we are concentrating the solar sun to produce heat, it is just to produce heat. If we are trying to produce electricity, that won't be efficient, I believe.
Okay, then the Stirling engine that then is used with parabolic dish. And between all this technology, I was showing to you that maybe it's the one that till now is not growing so fast like all the other one. To produce electricity really, and now there are a lot of the results coming already from the plants that have been constructed. When you use this linear parabolic 12, or when you use the tower system, you can really reach efficiency around 20%, and maybe you can get more according with the temperature that you are able to, the highest temperature that you are able to reach. With the Stirling engine, the situation is different. Then Stirling engine, you are ready to use in particular cases. It's just a very, very specific, but not for a mass production of electricity. That's what I agree with you. For a mass production of electricity, better to use the linear 12, the 12 system, with maybe, there are different technologies, maybe with the so-called mineral oil, IC transfer fluid, maybe with molten salt, maybe with gases. But then tower system also, nowadays, there is a lot of research going on the tower system. The tower system you can scale down to 1 megawatt, 2 megawatt, and then you can construct multi-tower system. And once more, the efficiency. There's still the dream that the efficiency of the tower can be larger than the efficiency of the linear 12. But both the Fresnel, also the Fresnel has not a very high efficiency, because then with the Fresnel mirror you are not able to concentrate a lot, and then the highest temperature that you can reach is around 200 degrees. Then you have to cover with some organic ranking cycles, etc. And also the efficiency is low, but then you have to use really in a specific case, but not for the electricity mass production.
Just one thing, just one thing. Just the solar piece. We are 1 hour out of the plan. لو سمحت دكتور
عافية. دكتور رمز القواس من جامعة بوليتكنيك فلسطين. سؤالي للدكتور عماد بريك. خلال عرض الدكتور مروان للبرزنتيشن ذكر انه عمليا غير مجدي استخدام طاقة الرياح لتوليد الطاقة اذا كانت سرعة الرياح اقل من 7 متر بير سكند. ولاحظنا من خلال المنحنى اللي عرضه الدكتور عماد انه في معظم اشهر السنة سرعة الرياح اقل من 7 متر بير سكند ما عدا شهر ابريل وشهر سبتمبر بتزيد عن 7 متر بير سكند. ففي هاي الحالة ما في عندكم تخوف من الاستمرار اللي هو 20% عن طريق الويند انرجي و20% عن طريق السولار انرجي؟ يعني ما فكرتوا انكم تواجهوا مشكله خلال الامبلمنتيشن لهذا المشروع؟ او انه يعني نفكر من هلا انه كومبليتلي نحول للسولار انرجي بدل ما نواجه مشكله في مرحله ما خلال تطبيق المشروع. شكرا.
تفضل في الدكتور مروان انه على نطاق تجاري حتى تكون مشاريع الرياح فيزبل لازم تكون عندنا سرعات رياح اعلى من 7 متر بير سكند، ولكن عند اي سرعات فوق الكات ان سبيد للتوربين راح يشتغل التوربين وراح يعطينا انرجي. هلا طبعا هل هو فيزبل من ناحيه ايش فيزبل؟ هلا المستشفى في عندها جراند، في عندها بروجكت اللي هو الويند توربين هذا، فبالتالي لها بالنسبه لها فيزبل انها تستخدم الويند توربين للبروديوسنج انرجي وتغطي 20% من الاستهلاك تبعها وتوفر 20% من تكلفه الانرجي السنويه للمستشفى. على نطاق تجاري زي ما حكينا، تفضل فيه دكتور مروان، على نطاق تجاري لامكانيه استخدام الويند باركس وعلى امكانيه استخدام الويند بشكل تجاري بحيث انه يكون الضاهي الكونفنشنال انرجي، يعني التوليد من خلال مصادر الطاقه التقليديه، صحيح لازم يكون عندنا سرعات اعلى من 7، ولكن بما انه احنا طاقه بنشتريها من مصادر اللي يعني شركه الكهرباء القطريه وهي نسبه سعر الكهرباء عندنا عالي جدا، فبالتالي ممكن نحكي انه امكانيه استخدام طاقه الرياح بتكون مجديه عندنا حتى عند سرعات ممكن تكون اقل بشوي من 7 متر بير سكند.
اخر سؤال لو سمحتوا، بدناش فيش مجال، فيش امامنا الا بس سؤال واحد لو سمحتوا.
سؤالي للدكتور عماد بريك، انا مهندس عبير هون من شركه ميلينيوم لصناعه الطاقه، بتعامل بانظمه الطاقه الشمسيه. حكيت انه بلزامكم 355 لاقط عشان توفروا 40% من استهلاك ديزل عمليه السبيس هيتنج والهوت ووتر سبلاي. فبقول انه 355 شو هو نوع 355 لاقط هدول؟ بعدين انت شايف انه 40% من هدول بيعملوا سيفنج. السولار انرجي ممكن يعمل سيفنجز كثير اعلى من هيك، ممكن يوصل ل 70 to 80%.
شكرا.
حسب طبيعه الاحمال الثيرمال الموجوده في المستشفى زي ما شفناها من المنحنيات اللي تم عرضها، تقريبا هي بتكون اكبر ما يمكن بفتره الشتاء، يعني اكبر ما يمكن بتكون بجانيوري فبراير مارس. فتم تصميم النظام بحيث انه يعطيني 50% من يعني نغطي 50% وليس 40 50% من استهلاك الثيرمال انرجي في المستشفى. ومع ذلك تصميمنا 50% كان في عندنا اوفر في الصيف بسبب انه في عندنا سولار راديشن عالي جدا واستهلاك الثيرمال كونسومشن في المستشفى بيكون قليل في الصيف. يعني عكسيه الشغله، فبالتالي تم تصميم النظام على 50%. طبعا ممكن تصميم النظام على 80 او 100%، ولكن راح يكون في عندنا ثيرمال انرجي فائض اكبر في فتره الصيف لا يمكن استغلاله، وراح يكون تصميم اوفر سايز بمعنى كوستلي. ولكن ممكن تصميم اي نظام احنا بحاجه له باي كباسيتي او اي تغطيه نيعه. فكنت اخذ 50% كبرومايز بين انه يكون في عندي فائض قليل جدا في الصيف، ولكن اقدر اغطي جزء من الاحمال خلال السنه كلها اللي هي 50% من استهلاك الديزل. النوع اللاقط اللي تم التصميم له راح ينزل في العطاء، وتحديد النوع مش راح يكون تحديد النوع في العطاء، ولكن اللي تم التصميم 355 لاقط اللي هي من خلال كوليكتر بايبس. يعني كوليكتر اللي هي راح تكون فلات بليت كوليكتر.
شكرا لكم، شكرا لاهتمامكم في الموضوع. دعوني باسمكم اني ارحب بالسبيكرز اللي عرضوا برزنتيشنز قيمه. ببداها بالدكتور جولزاري، دكتور عماد بريك، دكتور مروان محمود، والدكتور دقوانو. وللاسف ما قدرش نغطي جميع الاسئله لضيق الوقت، ولكن في مجال تقريبا 45 دقيقه لاي مناقشات ثنائيه. شكرا جزيلا لكم. بكون احنا بنهايه هذه الجلسه انهينا فعاليات اكاديميه لليوم الاول مؤتمر الطاقه الرابع. شكرا لاهتمامكم، ان شاء الله نشوفكم.